Selamat sejahtera. We are from Group F Section 2. Now we will be presenting about the lab experiment presentation for static laboratory. The title of our presentation is The Friction on an Inclined Plane. These are our group members, NAJMI, NAZMI, AMAR, SYAFIQ, and me, Yong.
I'm NAZMI. I will explain about the theory of friction of inclined plane. Friction on inclined plane is a classic physics problem that shows relationship between gravitational force, normal force, and frictional force. So, when an object is resting on an inclined plane, gravity pulls it vertically downward. The gravitational force may be divided into two parts, which is one perpendicular to the plane and one parallel to it. So, the perpendicular component suggests to the normal force, which is the force applied by the plane surface to sustain the weight of the object. In contrast, the parallel component pulls the object down the slope. So, the plane's angle of inclination influence whether an object say stationary or move. As the angle increase, the parallel component of gravitational force increase, whereas the normal force decrease. So there is a critical angle at which static friction can no longer remain the object, thus causing it slide down the plane. Understanding the balance of this force is crucial in many kinds of application, including engineering or daily occurrence, where friction on inclined surface is utilized to anticipate and regulate motion.
Hello, my name is NAJMI. For the observation, in this experiment, the block was first fixed, and it was observed that it moved very slightly when a small force was applied to push it. Because the block has static friction opposing the motion of the block, with the angle determined at which the block would slide 20 degree in test 1, together with the weight in newtons resulting in the slide of 0.55 newton. All other tests had the same angle. In test 2, the weight was increased until there was constant velocity to find forces of 0.55 newton and 20 degree. For test 3, the whole experiment started over as the plane was reset to 0 degree and the block produced enough force with 0.3 newton to get it moving. Increased to 20 degree, enough weight 0.5 newton was put on to keep it moving with a constant velocity. The successive trials at 30 degree and 40 degree limiting equilibrium at 0.6 newton and 0.75 newton respectively. The seventh experiment at 45 degree required 0.8 newton. In general, it was evident from the experiment that the limit of static friction force was directly proportional to the angle of inclination of the plane. This experiment hence characterized the angle full threshold force required to set in motion.
My name is Yong. Now, in this slide, I'll present about the results of our test on the angle of inclination of a plane and its effect on P, which is the applied force. We conducted 7 tests with angles ranging from 0 degree to 45 degree. The experimental values of P were compared against the calculated values, and the percentage differences between these two sets of values were recorded. The percentage difference varied, with the lowest at 3.163% for a 30-degree inclination and the highest at 9.141% for a 45-degree inclination. These results provide a clear insight into the accuracy of our calculations relative to the experimental outcomes, highlighting the relationship between the angle of inclination and the applied force. Now I'll be presenting about the calculation. For the first question, we are asked to calculate the coefficient of friction by using equation for test 1. So we will use the formula of mu equal to sin theta over cos theta equal to tangent theta to calculate the coefficient of friction for test 1, where the angle of inclination is 20 degree, and we can get that tangent 20 degree is equal to 0.364. For the second question, we are needed to calculate the value of coefficient of friction as well and the wake of block. for the angle inclination plane equal to 0 degree. So by using the equation W equal to mg cos theta, and given the mass of the block is 0.077 kilogram and the gravitational acceleration is 9.81 meter per second square, we can find that W is equal to 0.76 Newton. For the coefficient of friction, the mu is equal to tangent 0 degree and is equal to 0. This slide has highlighted the calculations are essential for the understanding of the experimental setup and results. For the third question, we are required to calculate the value of P for each angle, including the P at the angle of friction. So for example, for test 2, when the angle is 20 degree and mu is equal to 0.364, we will use the formula of P equal to W sin theta plus mu W cos theta to find P and is equal to 0.52 Newton. For other tests, for example at 30 degree, we can observe different values of P is equal to 0.2766 Newton in test race, 0.52 Newton in test 4, 0.6196 Newton in test 5, 0.7004 Newton in test 6, and 0.733 Newton in test 7. And this calculation has highlighted how different angles and friction coefficients affect the resultant force P and showcasing the relationship between the angle inclination and the frictional force in our experimental setup. In this slide, we are required to find the percentage differences between the experimental and the calculated values of P for each test angle, factoring in the angle of friction. The percentage difference is calculated using the formula percentage of difference is equal to experimental P minus by calculation P over calculation P times 100%. For test 2, with an angle of 20 degree and mu equal to 0.364, the difference is 5.769%. For test 3, the differences is 8.46%. For test 4, 3.846%, 3.163% for test 5, 7.082% for test 6, and 9.141% for test 7. These results has highlighted the discrepancies between our experimental and theoretical values, showcasing the reliability of our measurements and the influence of varying angles on the frictional force P.
Okay, now my name is MUHAMAD ZUKI. I will take over about discussion and question. I will answer all the discussion and question. Okay, for the first discussion, the question is discuss the values of P obtained by experiment and calculation. Compare those value with the force acting down the plane. So I answer this question with 5 points. First, this experiment overview. Measure force P required to move a block up an inclined plane. P equals the tension in the thread. Observation from this experiment as the inclination angle increased from 0 degree to 45 degree, force P increase. And the reason why, the greater inclination require more force to pull the block upward. Uh, the fourth point is force dynamic. Downward force S is smaller at lower angles due to the high friction. At lower angles, P is larger than S. And the last point is angle impact. As inclination angle increase, S also increase. Despite increasing S, P remain higher due to the ongoing friction. So it is simple 5 point to discuss this discussion A. Thank you. For discussion B, the discussion answer suggest to some reasons why there are difference occur between the values of P by experiment and P by calculation. I list up two reasons. The first reason why there has difference between calculation and experiment. First, parallax error. This is because occur when the eye is not perpendicular to measuring equipment. The second leads to inaccurate reading. And the second reason is surface roughness variation. Different material have varying surface roughness, effect friction value. Rougher surfaces produce greater friction force. So these two reasons uh, why have different between value of P by experiment and calculation. Okay, for discussion C, state the differences between friction on the horizontal plane and friction on the inclined plane. I had list up three differences between this horizontal and inclined plane. The first difference is direction of force. For horizontal, friction force at opposite to the motion. Inclined inclined plane, friction force parallel to the surface. And the second difference, magnitude of friction. For horizontal, normal force equal the gravitational force, and for inclined plane, normal force is affected by the angle of inclination altering the friction force. And the last difference between this plane is impact on friction force. For horizontal, consistent friction due to equal normal and gravitational force. For inclined, varying friction due to the angle affecting the normal force. Okay, next we go to question. I will answer question A and B. The question for A, what is the connection between the angle of friction and the coefficient of friction? Okay, I has list up 5 points to answer this question. The first is definition. Friction angle or theta represent the angle at which an object starts sliding. Theta is defined by arctangent of the coefficient of friction. The second point is mathematical relationship. Formula to find theta is tan inverse nu. Okay, third nature, dimensionless, quantifying the ratio of friction force to normal force. Geometrical representation, steeper angle indicates greater frictional force. And the last one, importance, central in understanding and calculating friction in various applications. And the last one, question 4B, explain two engineering application showing the significance of the friction on the inclined plane. I has list up two application. The first one is conveyor system. Why conveyor system? Because conveyor system used in industry to move material up an incline. Friction prevent item from sliding down. Engineers calculate the proper coefficient of friction for efficiency and safety. And the second one is road design. Friction between tires and road surface is crucial on slope. Engineers design road surface and gradients for maximum tire grip, ensure safe vehicle handling and prevent skidding, especially in adverse weather condition. For the overall significance, understanding and managing friction is vital for operational efficiency and safety in engineering application. So that's all for me. Thank you for question and discussion.
My name is Muhammad Shafiq bin Samsul, and now I will present a conclusion. Successfully validate the theoretical model demonstrating frictional force is proportional to normal force and influenced by the coefficient of friction. Accurate measurement of angles and force ensure reliable data. Challenges included maintaining consistent surface texture on the inclined plane, leading to variation in coefficient of friction. Protractor limitation result in minor inaccuracies in precise angle measurement. Manual application of force and subsequent measurement and also pose challenges. Further recommendation for future experiment include using a digital inclinometer, employing a more uniform and controlled surface material, and incorporating a mechanical system for force application and measurement. That's all from me. Thank you.
And these are the references that we use to complete our lab report.